The race back to the moon isn't just about planting flags anymore. This time, it's about who can build and sustain the first permanent human outpost on another world. China aims for 2030 with a full base by 2035. But here's what changes everything. What if you didn't need to ship base components piece by piece? What if your landing vehicle could become the base itself? SpaceX just revealed a plan so elegant it caught everyone off guard, including China's space program. Let's dive right in. Here's how traditional moon base planning works. NASA designs habitat modules on Earth, launches them piece by piece, then assembles everything on the lunar surface using specialized equipment that also has to be shipped from Earth. Each component requires its own launch. Each launch costs hundreds of millions. The timeline stretches across years, maybe decades. SpaceX looked at this entire approach and saw something everyone else missed. Why build a base when you can become the base? Once Starship delivers its crew to the lunar surface, instead of abandoning this massive vehicle, why not transform it into the foundation of the outpost itself? The concept sounds almost too simple, which is exactly why it's brilliant. But here's the immediate challenge. Starship stands 50 meters tall. How do you convert a vertical rocket into a horizontal habitat without massive cranes or construction equipment that would be impossible to transport to the moon? The answer comes from an unexpectedly elegant solution. After Starship lands, autonomous rovers prepare the surrounding terrain, leveling the surface and creating a stable foundation. Then a massive inflatable air cushion deploys beside the lander, wider than Starship itself and engineered to support its full weight. Two of Starship's retractable landing legs slowly fold inward, allowing the vehicle to tilt gently toward the cushion. The cushion compresses gradually, controlling the descent without sudden impacts that could damage critical systems. Once horizontal, the air releases slowly, lowering Starship onto the lunar surface. Now the real transformation begins. Rovers pile lunar regolith over the hull, creating radiation shielding, thermal insulation, and micrometeorite protection, all from materials already on the moon. Inside, the layout gets reconfigured from vertical to horizontal living. What was once a transport vehicle is now a pressurized habitat with thousands of cubic meters of usable space. Think about what this eliminates. Traditional approaches require transporting entire base components, assembly equipment, and construction machinery across 240,000 miles of space. SpaceX's method needs only a compact inflatable cushion system. Everything else, the habitat structure, life support, power systems, communication equipment, is already built into Starship before it even leaves Earth. The strategic advantage becomes clear when you look at the timeline. China publicly committed to landing taikonauts by 2030, then spending 5 years constructing their International Lunar Research Station with Russia as a partner. Their recent missions prove they're executing this plan methodically. Far-side landings, sample returns, consistent robotic exploration progress. If their schedule holds, they'll have boots on the moon and a functioning base by 2035. NASA's optimistic projection puts American astronauts back on the surface around 2027. That leaves roughly 3 years before China arrives. Building a traditional base in that timeframe is nearly impossible. It would require multiple space launch system flights, each costing billions, each carrying limited cargo, each taking months to prepare. The final result would likely be a small, cramped outpost with minimal expansion capability. But if the first Starship landing includes immediate base conversion, NASA gains a large, capable habitat almost instantly after touchdown. And here's what matters for long-term strategy. Starship's interior volume doesn't stay limited to initial crew quarters. As the base expands, those massive propellant tank sections can be repurposed into laboratories, workshops, storage facilities, and living space for dozens of astronauts. We're talking about thousands of cubic meters of pressurized volume, all from a single landing. Yet SpaceX faces serious skepticism, and the loudest voice comes from former NASA Administrator Mike Griffin. He rarely attacks Starship directly, but his criticisms focus relentlessly on orbital refueling, the system that makes lunar Starship missions possible. Griffin points out that reaching the moon requires multiple tanker flights, precise docking operations in orbit, and unprecedented propellant transfer at a scale never attempted before. In his view, this creates too many failure points. He stated the complexity makes success unlikely, and in some instances, he's suggested it simply cannot work. Griffin's alternative proposes returning to the architecture he championed nearly 2 decades ago: dual Space Launch System rockets. One SLS carries the crew in Orion, another SLS carries the lander. They rendezvous in lunar orbit, crew transfers to the lander, descends to the surface, completes the mission, returns to orbit, and flies home in Orion. Everything stays under NASA's direct control. On paper, it sounds straightforward and familiar. But the moment you examine costs and timelines, the entire proposal collapses. Consider what dual SLS actually requires. Developing a single SLS took over a decade and consumed tens of billions of dollars. Doubling that requirement means 2 complete rockets for every mission, each with separate production timelines, dedicated hardware, and extensive testing. Both need their own mobile launchers, and building just one mobile launcher has already proven extraordinarily expensive. Then there's the lander itself. Blue Origin's Blue Moon is designed to launch on New Glenn, not SLS. Is it even compatible? If not, NASA would need to fund either a complete redesign or an entirely new lander program from scratch. And here's what makes Griffin's proposal truly untenable. We're approaching 2026, with Artemis 3 scheduled for 2027. Rebuilding the entire lunar architecture now would guarantee massive delays. There's no realistic scenario where NASA could design, build, and test 2 operational SLS rockets, 2 mobile launchers, and a new lunar lander within the remaining timeframe. Adopting Griffin's plan wouldn't just increase costs, it would push American astronauts' return to the moon years into the future, possibly into the 2030s, meaning China would almost certainly land first. This is where Jared Isaacman's perspective becomes important. As the current nominee for NASA Administrator, he argues that dismissing orbital refueling is short-sighted. Both SpaceX and Blue Origin are investing heavily in the technology. The private sector is shouldering much of the development burden, reducing taxpayer costs. And when the system succeeds, it will transform missions far beyond the moon. Isaacman asks the question that cuts through all the debate. Are we trying to repeat what was done in 1969, or are we working to develop technologies that will open the entire solar system to human exploration? This is the real dividing line in the current debate. One side wants familiar, government-controlled systems that feel safe because they resemble past successes. The other side wants scalable, reusable systems that feel risky because they're attempting something genuinely new. But every major advancement in space exploration faced fierce skepticism before proving its value. Meanwhile, as these debates continue, NASA's current hardware keeps revealing its own vulnerabilities. The Artemis 2 crew was supposed to conduct a critical launch day rehearsal inside Orion on November 19th, but an unexpected issue forced a delay. A stain on Orion's thermal barrier prevented the hatch from closing properly during closeout demonstrations. Repairs were completed, and NASA insists the overall mission timeline remains unaffected. But each delay, each technical complication, reinforces a growing reality. Relying entirely on NASA's current internal systems makes the return to the moon far more challenging than it needs to be. While Orion deals with thermal barrier issues, SpaceX just crossed a milestone that underscores the vast gap in operational capability. The company launched another Falcon 9 from Vandenberg, delivering 28 Starlink satellites to orbit. This marked SpaceX's 156th Falcon 9 mission of 2024 and the 573rd Falcon 9 flight overall. Combined with Falcon Heavy missions, Starship test flights, and early Falcon 1 launches, SpaceX has now surpassed 600 total launches since its founding. That's not just a number, it's a demonstration of sustained execution at a scale no other organization has ever achieved in spaceflight history. This is the organization critics claim can't handle the complexity of orbital refueling. The evidence suggests otherwise. So here's what it comes down to. The moon race isn't about repeating history, it's about who builds the infrastructure that lasts, who establishes the systems that scale, and who gets there first while China's clock is ticking. SpaceX's plan to convert Starship into an instant lunar base isn't just clever engineering, it's the difference between arriving with a tent and arriving with a mansion. Traditional methods would have NASA launching components for years, assembling pieces slowly, while China plants their flag and starts construction. The Starship approach flips that entire equation. Griffin's dual-SLS proposal sounds safe until you realize it would cost double, take years longer, and still deliver less capability than a single Starship conversion. Meanwhile, SpaceX just crossed 600 total launches, proving they can execute at a scale that makes orbital refueling look less like a fantasy and more like the next logical step. The stakes are clear. By 2030, someone will have boots on the moon. By 2035, someone will have a permanent base. The question isn't whether Starship's approach is risky. The question is whether playing it safe actually puts America further behind. If you believe SpaceX's innovation gives the US the best shot at winning this race, drop a comment saying, "Keep progressing." Hit that like button, share this video with anyone who cares about America's future in space, and subscribe to Space Update 24 hours so you don't miss a single development in this critical journey back to the moon. The next few years will define the next century of human space exploration. Let's watch it unfold together.